This video introduces the broad topics that we are going to cover this semester. So at first, let us familiarize ourselves with some basic terminology. First of all, what is unit of observations, or what is case? Unit of observation or case refers to the entity from which data are gathered, and an example of unit of observations is data are gathered at the household level, are gathered at people, the level of people or individuals, or are gathered at the states level. An example is that Census 2020 asks household members about their age, race, and gender. So in this case, what is our unit of observation? So please pause the video if you need to think about the question and the answer to the question. So in this case, the unit of observations is household members, individuals, or people, because we see that Census 2020 asked who as household members. Another terminology is variables. So what are variables? Variables are traits that can change values from one unit of observation to another unit of observation. Some examples of variables are education, income, age. A specific example is Census 2020 asked household members about their age, race, and gender. So now the question for you is that what are the variables in the Census 2020 data? So you can pause the video to think about the answer. So there are three variables here. The first variable is age, second variable is race, and the third variable is gender, because these are three variables that were asked in Census 2020. So when we talk about variables, we also often talk about independent variables and dependent variables. In the causal relationships story, independent variables are usually the cause variable, the variable that caused something. And dependent variables are the variables that the effect variables. So independent variable is usually causing the dependent variable to happen or causing the effect. So that is in the language of causal relationships. A very important note here when we talk about independent and dependent variables is that correlation is not causation. So we will go over in detail what correlation means and what causation means later on in the semester. So in this class, there are two basic types of statistics that we will go over. And actually, statistics in general have two main types of techniques. The first one is descriptive statistics, and the second type is inferential statistics. So let's talk about inferential statistics first, and we will talk about the descriptive statistics. So inferential statistics is used to generalize from a sample to a population. So let's go over what sample is and what the population is. So population includes all cases in which the research is interested. For example, if we are interested in predicting the result of a US presidential election. So our interest here is on all voters in the US. So therefore, our population consists all voters in the US. Samples are subsets of the population. An example of a sample is that a sample is a subset of all voters in the US. For example, polls about presidential US elections is an example of a sample because we can only ask about the subset of voters in the poll. So in general, we usually only have data of samples, not the populations, and the reason is because samples are cheaper to collect. And that is why census, which in theory and in practice most of the time, what they try to do is to get the population data, and it only happens once every 10 years because it's very expensive to get or to collect data of the population. So appropriate statistical technique gonna help us make a conclusion about the population from a sample. So that is inferential statistics, where we have a sample, but inferential statistics is going to help us to make a conclusion about the population, which we don't usually have. So what is descriptive statistics? Univariate descriptive statistics describe or summarize variable one at a time. Some measures used in univariate descriptive statistics are percentages, averages, and various charts and graphs. Example, let's say on average, undergraduate students in a university are 20.3 years old. So in this case, what is the unit of observation, or what is the case in this example? Pause the video, think about the answer for a moment. So the unit of observation in the example is student. What is the variable of interest in this example? The variable of interest in this example is age. So for these two questions, I just want to draw back to what we discussed about unit of observations and variable of interest. And the type of statistics that we use in this example to describe the age variable of student is the average. Because we talk about the average age. Another type of descriptive statistics is bivariate or multivariate descriptive statistics, where we describe or summarize relationship between two or more variables. And these statistics are called measures of association. An example of measures of associations are multivariate descriptive statistics is when researchers are interested in the relationship between student age and GPA. And let's say if they find that older students have higher GPA. So this is an example of what bivariate or multivariate descriptive statistics look like when we are not only interested in one variable such as age or GPA separately, but we are interested in the relationship between the two variables, in this case, student age and GPA. So that is a descriptive statistic of bivariate or multivariate statistics. So now I want to draw back to what we discussed in earlier slides about unit of observations and variables. So in this example, tell me what is the unit of observation here? Students, again, because we are interested in students' age and GPA. And what are the variables? The variables are age and GPA. So I want to make a quick note here that measures of association cannot, by themselves, prove that the two variables are causally related. So with all of that terminologies are introduced, so now we will talk about the overall big picture of what this semester is going to cover. And the first part of the semester is going to cover descriptive statistics, where we gonna learn about how we summarize data, how we describe our data using graphs and different descriptive statistics. Then we're going to move on to talk about something completely different, which is probability and normal curve, which we will think about how we can systematically think about uncertain events. And the reason why we have the topic of probability and normal curve is it's going to help us to think about inferential statistics, where we're going to use our knowledge of probability, normal curve, and uncertain events to think about how we can infer about the population from a sample. And the concepts we are going to learn is confidence intervals and hypothesis testing. Then the final broad topic we are going to cover is regression. And here we're going to use our general understanding of descriptive and inferential statistics that we learned earlier to learn about the relationship between multiple variables. In this broad topic of regression, we're going to emphasize and focus on the difference between correlation and causation, and knowing that they are not the same. And we will learn when regression give us or when they do not give us causal relationship to make policy recommendation.